Okay, so here is the solution, right? Now this is Earth, this is the twin planet, right? What's the force? Force of gravity. So let's start. So let's say if you had let's do this here. So this is, let us say, Earth, right? Now the acceleration due to gravity is how much? So this is g, which is equal to 10. Right? Now what is g equal? What is the formula for g? So g is equal to g, right, mass of Earth upon r square, where r is the distance between the distance from the center of Earth to where the object is located. Right? This is for a small object on Earth's surface. Right? Okay, so now if it's not at Earth's surface, let us say it was at some distance here, then this r just becomes the, let's see if I take an object at some height h. So the Earth's surface, let's call it capital R, and let's say I take an object which is, say, height h from Earth's surface. So here my r is going to be nothing but h plus capital R, right? And therefore this would be h plus capital R whole square. So this would be g at this height, this would be g me, right, upon h plus capital R whole square. Now if we use this, we can solve this problem very easily. How do you do that? So this planet, right, there is a property of if you have uniform density sphere, right, then to calculate the force of gravitation, we can treat as if outside that sphere, right, it will behave as if all the mass was located here. So which means I can treat this planet as a point mass which is at the same distance, say it is at a distance at r from here, right? So if I take this distance, now here when I take this whole thing, right, my h is equal to r for this situation, right? And this whole mass can be thought of here. So there is mass of Earth at this point, which is distance r from here. Now if you think about it, right, so what is the force of gravity going to, what is the acceleration to gravity here? So that would be, so g, right, at a distance of g for h equals r. What will that be? That will be nothing but, this was gme upon r square, right? So from here on Earth's surface, right, on Earth's surface would be gme upon r square, and that is equal to 10. Here what do we have? Here we have this upon gme upon distance is now 2r upon 2r whole square, which will be equal to 1 by 4 into gme upon r square, which is, and this value is nothing, this is 10, right? So this is going to be, so at this height your acceleration to gravity, right, would be g at a distance r at a distance h equals r, right? For this condition, right, my g is going to be 10 by 4, which is equal to 2.5. Right? So if you have a point mass here, what will be its weight? Mass into gravity, right? So your weight for the weight of twin planet, right, weight would be how much? That would be mass 6 into 10 to the power 24, right, into 2.5. What is this? So this is 6 to the 12, 5, so this is going to be 15, right, 15 into 10 to the power 24, or I can say 1.5, right, into 10 to the power 25, what units? Newtons. This is the answer. So we have now, I'll write it here, so weight of twin planet, right, is equal to 1.5 into 10 to the power 25 newtons, right? This is the answer, and as you can see, it didn't require a lot of calculations, right? Some fairly basic, straightforward concepts, and those of you who got this right, and if you used a shortcut, simple method like this, congratulations. Thank you.